Hello and welcome to a very special episode of 52 Weeks, 52 Scientists. Today we are covering Albert Einstein, the person who is almost synonymous with the word genius. So he was born on the 14th of March 1879 in Ulm, Baden-Württemberg in Germany. Now let's talk a little bit more about his life. So he is considered the father of theoretical physics, which is a branch of physics that employs mathematical models and abstractions of physical objects and systems to rationalize, explain, and also predict natural phenomena. He is considered by many people to be one of the greatest physicists of all time. Yes, all time. He's considered so because of his many discoveries that we will get into one by one, discussing all of them. So let's get started with those. So he did the theory of relativity, which tells us that the laws of physics are same in all the inertial frames of reference and that the speed of light in the vacuum is constant regardless of the motion of the observer. To simplify it a bit, it basically means the speed of light when in a vacuum, when nothing can enter, is constant. It's going to stay the same regardless of how you move or how you see it. That's the theory of relativity explained in very short. He also was a pioneer of quantum mechanics, which is a fundamental theory in physics that provides a description of the physical properties of nature at the scale of atoms and subatomic particles. So, very small things. It is the foundation of all quantum physics, including quantum chemistry, quantum field theory, quantum technology, and of course, quantum information science. One of the things that's being studied about and that could totally change the world is quantum computing. I suggest you check out some of the resources I've attached in the description if you want to learn more about this. Now let's talk about that famous equation, the elephant in the room perhaps. That is E equals mc squared, or energy mass equivalence. Basically, this stipulates that energy is equal, that the energy of a particle rests in its rest frame is the product of mass with the speed of light squared. So first of all, square the speed of light and then multiply it with mass. That is energy. There's a relationship between mass as well as energy when a system is in rest, when it's not moving. And the two values differ only by a constant and the units of measurement. So I hope you understood that. Let's talk now about his other work, which was mostly related to his philosophy of science. He worked in the two. His philosophy of science work included many branches, but he was also always obsessed about finding about nature. He received the 1921 Nobel Prize in Physics, and I quote, for his services in theoretical physics, and especially for his discovery of the law of the photoelectric effect, which is a pivotal step in the development of the quantum theory. And this is why Einstein has become synonymous with the word genius, because he made many big discoveries. Well, it all boiled down to a halt in his Annus Mirabilis, or miracle year, 1905. In 1905, he published multiple papers, 4 papers, and we will describe their subjects and the subject of his other work in just a couple of seconds. Alright, so let's talk about the first. So the first thing that he did study on was the photoelectric effect. Now, photoelectric effect is the emission of electrons when electromagnetic radiation such as light hits a material. Electrons emitted are called photoelectrons, right? The electrons that are emitted when light hits a material, these are called photoelectrons, and the effect that surrounds them is what he did his research on. He also worked a lot with Brownian motion. Now you might ask me, what is Brownian motion? So let me take a little bit of a time and let's talk about what is Brownian motion, or Pegasus is the random motion of particles suspended in a medium, a liquid or gas. So imagine this. There's a tightly closed container and there's some gas in it. Now the movement of particles inside this, that will be called Brownian motion. And I've put a simulation here so that we can see that. So he then worked on special relativity. Now, what is special relativity, you ask? Basically, special theory of relativity or special relativity is based on two postulations. One of them is that the laws of physics are invariant, that is identical in all inertial frames of reference. So, without acceleration, any frames of reference will give you an invariant laws of physics. The other is that the speed of light in vacuum is same for all observers, right, regardless of the motion and the light source or the observer. That does not matter when you are learning about the speed of light. So these are the two learnings, you could say, from special relativity. One of them, when are laws of physics invariant? The other, the speed of light in a vacuum. Anyways, he also did general relativity. Okay, so let's take a little bit of a moment, and by a little bit of a moment I mean a couple minutes, and let's discuss in detail general relativity. It's also known as Einstein's theory of gravity, in the geometric theory of gravitation, and in the current description of gravitation. So when you learn about gravitation in school or in college, you're basically learning about Einstein's general relativity. So Newton's law of universal gravitation can be seen as a prediction of general relativity for almost flat space-time geometry. But these predictions concern the geometry of space. How does space look? The motion of bodies when they are free fall, the propagation of light, how light spreads, and includes gravitational time dilation, gravitational lensing, redshifts, a lot of things. The Shapiro time delay, singularities, black holes, a lot of that. Basically, the Einstein field equations give us that a unified description of gravity as a geometric property of space and time of four-dimensional space-time. You were waiting for that word, weren't you? So we have discussed this, right? Let's now talk about what other things he did work on. One of them was statistical mechanics, the other quantum theory. He was always obsessed with quantum theory, but then he renounced it, saying nature doesn't play dice, because people were being way too open about it. He also did work with particle theory and the motion of molecules. He was concerned with particle physics a lot, and his work describes, for example, his theory on Brownian motion. They all somehow concern particular and molecular motion. He also invented the photon theory of light. Now, the photon theory of light, before going into much detail, is that it's based on a type of elementary particle that serves as the quantum of the electromagnetic field. That's a very short explanation I can give you. Let's now talk about his unified field theory. So, for decades, scientists have been trying to find a way to merge all kinds of physics concepts and laws into one theory. It's a type of theory that concerns all branches of physics, right? Classically, a duality of fields is combined into a single field. So he did the general theory of relativity. That's what he tried. The theory of everything, suggested by none other than Stephen Hawking, who we will get to in one of our episodes. The grand unified theory, which is another model. It has been suggested by the simple provided by Howard Georgi and Sheldon Glasler, then Abdus Salam and Yogesh Pati, then took to refine it. Basically, a unified field theory is a type of field theory that allows all usually thought fundamental forces and elementary particles to be written in a terms of affair of physical as well as virtual fields. In short, He tried to make a theory for all physics and failed. Alright, let's now talk a little bit about his political history. By political history, I mean where was he situated. So, he was born, as I said, in Ulm, in the Kingdom of Württemberg, in the German Empire. He was a citizen for 17 years. Then he got scared he would have to do military service. So, he was stateless for until he turned 22. When turned 22, he became a Swiss citizen. He kept his Swiss citizenship until his death. He would then became an Austrian citizen when he returned back to Berlin and to join the Prussian Academy of Sciences and the Humboldt University of Berlin. So he was part of the Kingdom of Prussia from 1914 to 1918, Austria from 1911 to 1912, and the Free State of Russia and the Weimar Republic from 1918 to 1933. In 1940, he sought asylum in the United States. Now, why did he? In 1933, he sought asylum. He lived in the started living in the United States. In 1940, he received a citizenship. Okay, let's talk about that asylum thing now. So, he had a relationship with. I'm not gonna mention his name because I don't want to be demonetized. YouTube, please don't do this. Basically, he opposed him. He was a Jew, not a practicing Jew, a secular Jew, but a Jew nonetheless, and he feared being prosecuted, and that was the reason he went to the United States. When later he was offered the presidency of the state of Israel, he rejected. He didn't even like the idea of forming the state of Israel. However, he did form the Hebrew University in Jerusalem. His relationship with this man was that of a very serious enemy, you could say. He died on the 18th of April 1955 in Princeton, New Jersey, USA, where he was professor until his death. He refused to be operated on, and a legend went away. So his history is full of small imperfections and a way to see history very differently. I hope you enjoyed this video. I had a lot of fun making this video. Please make sure to subscribe, and I'll meet you in the next one. Bye-bye.